All right, for 2.3, if you remember back when we were practicing factoring in Unit 1, I reminded you that factoring was not going away, so we're going to continue factoring with quadratic equations. Just a couple items of vocabulary and definition that I want us to understand, because you're going to be seeing the words roots, x-intercepts, and zeros a lot in this unit, especially this section. So roots, another word for roots, or what roots just mean, are the solutions of an equation. Okay, so if we have a quadratic equation, ax squared, let's put it in standard form, plus bx plus c. It's an equation, so it equals, we'll just say 0. The roots are the x values that make this equation true, or that solve this equation. Okay, we're going to talk about, and you might be able to tell from the title of this section already, that the way we're going to solve for those x values is by factoring. Okay, x-intercepts we've talked a lot about before. It's just the points where the graph crosses the x-axis. We can put that up here. Points where graph crosses x-axis. So we talked a lot about the y-intercepts back in 2.2, graphing in standard form. Your x-intercepts, you can sometimes have 2. Let's do one of each. You could sometimes have 1 if the vertex is on the x-axis, and then you could potentially have no x-intercepts if that parabola is above or below the x-axis. And you'll see an example of each, either this lesson or the next lesson. Zeros. The zeros of a function are where the function equals 0. So if we had the function f of x equals 2x squared plus 3x minus 5, the zeros of this function are the x values after you set f of x equal to 0. So 2x squared plus 3x minus 5, and then just like the roots, you would solve this equation. You first try by factoring, and those would be the zeros of a function. Really what I want you to understand is that the x-intercepts, zeros, and roots, they're all asking you to solve for the same thing. You're solving for the x's of a function. Okay. One important piece that we're going to use when we're solving for any of these is after we factor, we're going to use something called the zero product property. Okay, and this states that if the product of two quantities equals 0, then at least one or both of those quantities must also equal 0. Okay, and a way I can illustrate that for you is if you had some product, so A times B, and A times B equals 0, then either A needs to equal 0 or B needs to equal 0, because anything times 0 is always going to get you 0. So when you factor all the way down, we're going to take our products and we're going to set them equal to 0, and that's how we're going to solve for our zeros, our x-intercepts, our roots. Let's go practice some examples here. Finding the zeros or x-intercepts of these quadratic functions, and then we'll go ahead and graph too, okay? Because the x-intercepts, they're going to give us 2 points most of the time. And then we can graph, and it'll help us practice finding the vertex again in standard form. Let's start on number 1 together. Set the function equal to 0. And we're right back to our factoring steps. I like to take out a negative so you don't have to deal with the leading coefficient being negative. So now we have x squared plus 2x minus 3, a little bit easier. We're looking for factors of negative 3 that add up to positive 2. So that would be our plus 3 minus 1. And then we're going to set both of these terms. And this is your zero product property right here. Two products equaling 0, or two terms being multiplied together that equal 0. We're going to set both of them, and you can use the negative if you want. It doesn't matter, because if you distribute the negative, it makes them both the opposite. It won't change your solution. We're going to set both equal to 0. So x plus 3 equals 0, x minus 1 equals 0. One or both of these products need to equal 0 in order to get 0 as your solution. We move the 3 over, we get x equals negative 3. We move the 1 over, we get positive 1. These are the zeros of our function. They're also the x-intercepts. So let's go put a point at negative 3 and positive 1. There's another easy point we could find on here, or use on here. Positive 3, the last value in standard form, if you remember from the last or the previous section, that's our y-intercept at 3. And then let's find the most important part of our graph. Let's find the let's find the vertex using negative b over 2a, our axis of symmetry equation. A negative 2 becomes positive 2. 2 times negative 1 is negative 2. So we get our axis of symmetry in negative 1. That looks correct because it looks like it's splitting those zeros down the middle. And remember this, all of our parabolas or our quadratics, they need to be symmetrical. Let's get the y-coordinate by plugging it back in. So negative 1 squared minus 2 times negative 1 plus 3. Negative 1 plus 2 plus 3, which gets us 4. So our vertex would be at negative 1, 4. Great. We definitely have one more point on the other side of that axis of symmetry, because all parabolas are symmetrical. And there's our function opening down, because you have a negative a value. Domain, all real numbers. Range, everything below whatever the y-coordinate of your vertex is, less than or equal to 4. Okay, great job. Let's try number 2. And then we'll let you try 3 on your own, and we'll finish up with 4 together. Okay. Number 2, find the zeros. Set the function equal to 0 first. So 0 equals x squared minus 8x. Remember your first step in factoring. We only have 2 terms. The only way we can factor a binomial is if it's a difference of 2 squares or there's a GCF. You have a GCF here. The GCF, greatest common factor, is x. We're left with x times x minus 8. Set them both equal to 0, so we get x equals 0. X minus 8 equals 0, which means our 2 zeros, or the 2 roots of this equation, or the 2 x-intercepts, are at 0 and positive 8. Our y-intercept is also at 0 because there's no c value, so that checks out. Last thing we need to do is find the vertex. Negative 8. Positive 8 over 2. That makes sense because 4 is right between 0 and 8. Plug your 4 back in, we get 16 minus 32, so negative 16. Our vertex is at 4, negative 16. Let's see if we got enough room on here. 1, 2, 3, 4. Oh, we go a little bit into this function, but that's okay. We'll stop right there. and all the way up. Great. I'm okay with you graphing 3 points at times if that's all you have. It's less work. If you wanted another point, just pick any of these. You could plug in 2, you could plug in, I would either plug in 2 or 1. Keep those numbers nice and small, but that would be our function. Let's list the domain and range. Domain would be all real numbers. Range would be y is greater than or equal to whatever the y coordinate is of your vertex, so -16. Okay, why don't you guys try 3? 3 is tough because you're going to get some fractions for your vertex, okay? But you guys got it, and remember, the leading coefficient is not 1 here. The leading coefficient is something other than 1, so you're looking for factors of 4 that add up to -5. Okay, I'll give you guys some time to solve this. Video will pause. You want the zeros, the vertex, and then graph. If we are factoring, you should have gotten x minus 2 times 2x minus 1 when we set both terms equal to 0. We were going to get an x-intercept at 2. We were going to get an x-intercept at 1/2 after you add the 1 over and divide by 2. Great. 2 and 1/2. So our vertex is going to be somewhere in between 2 and 1/2. Going to be a fraction. That's fine. After using -b over 2a, you would have gotten 5/4, okay, or 1 1/4, or 1.25 as the x-coordinate. Okay, we're going to plug the 5/4 back in. So I'll work this out with you guys. 2 times 5/4 squared minus 5 times 5/4 plus 2. So we get 25 over 16, 25 over 4. See, 2 goes into our 16 8 times, so we have 25 over 8 minus, we need to write this with a denominator of 8 as well, so minus 50 over 8, and then let's write the 2 with the denominator of 8, 16 over 8. So we get -25 over 8 plus 16 over 8, which leaves us with a -9 over 8, or about -1.125, not about exactly. So slide this over. Our vertex would be at 1 1/4 and -1 1/8, which would be 1.25 right here. -1 1/8 just barely past, probably a little bit closer. So our vertex is going to be right here. If we want another point, use the y-intercept. 2, you need to go 2 units, or sorry, not 2 units. You need to go 1 1/4 units on the other side, so there's 0.75, and then there's 1/2. You'd be exactly at 1/2, and there's your parabola. Okay, great job. Most important part really of this lesson, finding the zeros by factoring, okay? Great job setting it equal to 0 and finding your factors. All right, let's finish up with 4 together, and then we'll talk about finding the roots of equations. It's going to be pretty similar to what we've been doing. For 4, set this equation equal to 0. We're looking for factors of 12 that add up to -13. They both need to be positive, so hopefully we can see that 12 times 1 would be our 2 factors. Let's factor out using all of our steps. So 3x squared plus 12x plus x plus 4, and then we group it. We can take out our 3x, we're left with x plus 4. If you already have x plus 4, we're going to use 1 as a placeholder. We have x plus 4 times 3x plus 1. You could have gotten the same 2 binomials if you use guess and check. Set them both equal to 0. We get x equals -4, and x equals -1/3 for our 2 zeros. -4 and -1/3. Right here. Great. Great. We don't really have room for our y-intercept on here, so we're going to skip that point for now. Let's go find the vertex. You're going to have some messy fractions here. It's okay. Negative 13 over 6, which is about negative, or not about, it's exactly negative 2.2. And then for the sake of time and all of our messy fractions, I'm going to save us from plugging that in. You would have got negative 2.2 and negative 10.1 for your vertex. So negative 2.2, negative 10.1. Great. And there's our function. Pretty narrow, pretty squeezed together because the a value is 3, vertical stretch by a factor of 3, right? We didn't really talk about that on our other graphs. Squeezed together on 2 because it's a vertical stretch of 2. But great job. Most important part of this lesson is that you can solve for your x-intercepts or your zeros by setting the function equal to 0. Okay, last thing is we might just have a quadratic equation. We don't have a function, we just are solving for our x values. It's a quadratic equation because you have some part of x squared in your equation. And really, you're just going to solve by getting the equation equal to 0 and then factor, so nothing changes here. So let's move our 40x over. Don't forget, you can always take out a GCF. That 4x squared and 25 should be two really important numbers that you guys notice. Those are perfect squares, so this is actually a perfect square trinomial. We can factor this as 4x minus 5 times 4x minus 5, or 4x minus 5 squared. And then a couple ways you could solve this here. We don't really need to include the 2, it's just our GCF, so you can just take this binomial, 4x minus 5, set it equal to 0. You don't need to do it twice because you're going to get the same thing, right? So just once is fine. Add the 5 over, divide by your 4, get x equals 5/4. So only one solution to this quadratic equation. If you were to graph this function, instead of 0 you had f of x, that would look like this, where you have at 5/4. That's your one solution, so it would be the vertex. The vertex would be at 5/4. But if it's just our quadratic equation, don't need to worry about graphing, we're just solving. There's only one solution that was going to work here. Okay. Let's try 3 together. Actually, let's try 4, and you guys can finish up with 2 and 3. Set this equation equal to 0, so I would move that 1 over, and you have a difference of 2 squares. 3x minus 1 times 3x plus 1. So we get 2 solutions here after you set them both equal to 0. Let's not skip that step. 3x minus 1 equals 0, and 3x plus 1 equals 0. So we get x equals 1/3, x equals negative 1/3. There's another way you could solve this equation if you'd like. If you just have 2 terms, like 9x squared equals 1, you could just start solving for x by isolating. So you could divide by 9. You have x squared equals 1/9. Get rid of the square by taking the square root. Square root of 1/9 is just 1/3, and don't forget when you take the square root of an equation, you have plus or minus, which is why we get the positive 1/3 and the negative 1/3. All right, why don't you guys work out number 2, and we'll check the solutions when you are done. This was also going to be a difference of 2 squares. Sorry, not a difference of 2 squares. A perfect square trinomial. It was going to factor down 2, 3x minus 4 squared. So you're going to have one solution here. X was going to equal 4/3. If you wanted to plug it back in to check, you definitely can. For the sake of time, we're not right now. Go ahead and try number 3. move the 4 over. We have a perfect square trinomial. X minus 2 squared equals 0. You only need to set it equal to 0 once. When you see x minus 2 equals 0 twice, and we get one solution at 2. Okay, let's just show really quick. This one's easier to plug in. When we plug it back in, our equation should be true. We get 4 minus 4 times 2, which is 8, equals -4. -4 equals -4. If you have time, especially on a test or a quiz, take it and check your work. Okay, that's it for solving quadratic equations by factoring, or finding the zeros or x-intercepts of a function by factoring. We'll practice more on the homework and later this week.